Okay. So if you see, there is a three types: ML, supervised, unsupervised, and reinforcement learning. So, Anu, you are there, right? Supervised learning means what? Do you
No,
remember?
no, I was not there. I joined after half an
Uh,
hour. So, yeah.
okay. So once, okay, theory part you don't know. Okay.
Yeah.
Okay. Let's give a quick. Actually, supervised learning is something like when there is a label data, when any
Yeah.
algorithm apply, that is supervised learning. If there is a
So we
label data.
can we say if it is an known inputs and outputs, right? That means.
Yes, yes. Label data means there will be input and output.
Okay.
Unsupervised learning means unlabeled data. And here, trial and error. Okay. So label data means there in the data you will have input feature also, output feature also. But in unlabeled data you will have only input features. Okay, you got it. So whatever you discuss these things, see these inputs here. Is this data set is a label data? Can I say
Yes, it is.
Yes.
yes? Because we have input features and output features. So this kind of data, which means see now you are applying algorithm on this data, which means what this is a supervisor learning algorithm. You got it.
Yeah.
So which means supervised machine learning algorithm means if any algorithm which apply on label data you call it supervised learning algorithm. If any data apply on unlabeled data, that is called unsupervised learning. Okay. And reinforcement learning means there is a trial and error. Their learning will be trial and error. Okay. Like if I take, have you played any sudoku game?
Yes.
Yeah. So what you do there, your ultimate goal is from source to destination, right?
Correct.
Sudoku, or there is a mouse, there will be a mouse in the like one rectangular shape. There will be so many boxes there, one mouse from source to destination it has to reach. That kind of game have you played?
No, I mean I played only numbers, right? That we need to fill our numbers.
Okay, okay. There are the some more game also, like there will be there are the certain paths only to from a source to destination you have to reach, but there are the certain path. When you go forward there will be a block, again you have to go back and again you have to see different path. Have you played all kind of things? If you see, let's see, this is a box. Let's say this is a box. Now you are here. Now here you have to reach.
Okay.
Yeah, like similar to Ludo, right?
Yes, yes, it's kind of.
Ludo. Okay. Yeah, that's right.
Yes.
It's not Ludo exactly.
Like,
It's kind of okay.
Yeah. Now I need to reach from here to here. This cross marking is a blocking marks. Okay. Now I need to for this person I can go how many paths I have to go? How many way I can go forward?
One, two, only one way, I guess. No,
Is
two
there
ways.
one way?
Two.
Two way? Diagonal also you can go.
Yeah, correct. It's a diagonal.
Here
Three,
one way, two way,
four,
three way.
five. Yeah, I mean more than five or six
Yes.
actually.
Normally for any cell you have how many?
Four.
If I
Uh,
see here
four
one,
ways.
two, three, four, eight way,
Eight.
right? But for
Yeah.
this only you have three because it is a corner one.
Yeah.
Okay. Now my ultimate goal is what, from here to here. Now I can take this step, this step, and this step, but you don't know what step you need to take, right? Let's take, I took this step. For this step, how many way I can go? One, two. Diagonally, can I go?
No.
No.
Yes.
Diagonally, this is a cross mark, which means you cannot go.
Okay.
Cross means blocking. You cannot have path. Now I can go either I can go here, here, I can here, I can here, I can go here, I can here, I can go here, I can go here, I can go. This is one kind of a path, right?
Yes.
Can I say? Suppose instead of taking this path, if I took this path, only way I can go here, here, which means what? You block here. Can
Yeah.
I go forward from here to here? No. Which means what? This is a you tried something, you got error here. Here you got error, which means you are not going, not able to go forward. Which means what you learned, this is a path I should not go. Again, you will go back, you will try different path. If that path also is blocking, again you will try different path. Right? How you that is nothing but a reinforcement learning. You are learning depends on the trial and error. You try something, you are getting some error, right? The way you learn. If I take a good example, suppose let's take it. There is a let's take it. There is a person one. There is a person two. This person one knows fire. Person two don't know the fire. Do you guys know, right? If you touch the fire, what will happen?
It will burn.
Yes, yes, right. Did
Yeah.
you know the same thing during childhood?
No, we don't.
How you got to know?
Once we touch it, then we got to know.
It might be in two way. You might be know, right? Either supervised learning or reinforcement learning. Supervised
Yes.
learning means what? Either someone told you, like, don't touch it, you will get hurt. That is a supervised learning because someone supervised you not to do. Am I correct?
Yes.
Another way, what? If in the childhood, if you touch, you might get hurt, right? That's why
Yeah.
you thought like, no, this is something you are getting error. You are hurting means what? That is kind of error, right? Now you tried something, you touched, you got hurt, which means what? You tried, it got error. You learned something right there. What
Yes.
is the learning you got? In the future I should not touch. That is called reinforcement learning, and these learning algorithms are applied on gaming.
Okay.
Okay. So anyhow, but in machine learning, the reinforcement learning don't study much. Only you focus on like supervised learning. Anyhow, the industry like whatever the you go to industry, the whole all the algorithms are supervised learning and unsupervised learning. And this reinforcement learning is comes like in deep learning, in uh, in deep neural network. So we'll study in deep learning. Okay. And as of now, supervised learning and unsupervised learning. Okay, we'll study in the MSc learning. Okay. So have you at least you got to know what is supervised learning, or what is unsupervised learning, and what is reinforcement learning?
Yes, sir.
Yeah. So now, can you able to tell one unlabeled data example?
Um,
Let's take. I will tell. You tell that is the labeled data or unlabeled data. Let's say. Can I say this is a one data I have shown to you? whatever you see, those are, can I say whatever you see, these all are inputs to your eyes. Can I say it?
Yes, sir.
Uh, do you have here any output label?
No.
No.
Why not? So now you understand input means output means output levels means if I have written circle here, the circle is a output level for this structure. You got it? So here,
Okay.
whatever you see here, the whole thing is input. If I see if I show this input to you by seeing the data, what you understood,
I mean,
what
there
can
are,
you do?
we can segregate circles,
Yes, exactly.
angles.
We can only segregate,
Yeah.
right? We can only segregate the data. When there is unlabeled data, we can only segregate, which means, so in unsupervised learning, unsupervised learning is unlabeled data, only clustering algorithms are there. You got it?
Okay. Yeah.
Clustering algorithm. You will have so many clustering algorithms. If there is unlabeled data, only thing you cannot predict, you cannot classify. Only you can do is segregate. Segregate means what? Classification. Okay. How it, where it use? Do you have any idea? Like already you using this, you experienced also. Do you have any idea where it is using classification?
Classification.
This is widely used in like recommendation system.
Which one?
This algorithm also used in recommendation system. Recommendation.
Like
Uh,
ads, advertisements that were targeted advertisements in Netflix.
yes,
I
yes,
think
yes.
Netflix.
Yeah, targeted advertisement. They will segregate. Depends on the data, they will segregate. Which means what? They will classify for the this kind of people. This is a young people, old people, or business people, or working people, IT people, labor work people. See, depends on their data. The company what is does na, they will segregate. They will some customer will have so many customer. Out of so many customers, they will segregate. Out of so many customers, some might be a business people, some might be IT people, some might be like working in somewhere, and some might be labor people. They will segregate. Then they will start giving advertisement. You got it? There they use this clustering algorithms. Okay, you got it?
Okay.
Yeah. How they cluster, how clustering algorithm works, how do you segregate, all those things we'll study in further class. K means algorithm, KNN algorithm will have. So as of now, just know the overview. What are the three things? So do you get already these all things I have taught in the first class, but as you guys are not there, so I taught again. So you got it now?
Yes, sir.
Yeah. And what about Monica? You got it?
Yeah. Yes, I got
Yeah.
it.
Okay. So this linear regression algorithm, did you guys understand?
Ah,
Why to use linear regression?
To predict optimal parameter values.
Okay.
That's it.
So linear regression we use to find optimal values. Okay, correct. But what is the ultimate use of this algorithm?
To reduce the error. Of course.
These are the fine to find out the model you do. What is the application of this algorithm?
For is it for numerical inputs? We do it.
I think you went into only algorithms. And like I told, right, linear regression, where we have to use. Come here. I think you guys are not there that day. Okay, let me revise once. Okay, that notes is not there. Okay, so linear regression, when output is continuous, we apply this algorithm. Okay, if output is continuous, we apply this algorithm. But what is the application? Is a prediction.
Okay.
It's a prediction of output, right? Prediction of continuation value. Can I say prediction of a house price? Can I say
We
prediction of
can.
how much how much loan you are eligible?
Yes.
So see, output can be anything, right? Loan can be anything, right? It can be 1 lakh, 2 lakh, 3 lakh, 4 lakh, anything. 1.5 lakh, 1.25 lakh, right? You are predicting what kind of data?
Numeric.
Numeric but continuation data.
Continuous data. Okay.
You got it? It's a
Yeah.
numeric but continuation data. Why you call continuation data? Because that numeric can be anything. Are you getting?
Okay. So the continuous data and which is numeric, we use linear regression.
Yes. So now one more example. Let's take suppose there is a finance company. You applied some loan. They will see your detail, all things. They will say either you are eligible for loan, yes or no, right? Their output is what? Either yes or no. How
Yeah.
many levels are there? How many possible outputs are there?
Only two.
Only two possible output. But in predicting house price, possible
No,
output can be
anything. I mean, we can.
anything,
Yeah.
right? That is a continuation value. But here, either yes or no. This data you call it what? Categorical data.
Okay.
You got it? Now?
Mm.
Yeah. Now, whatever you studied linear regression, those all that algorithm applies on only continuation output only. You got it?
Okay.
Now, if there is a categorical data, what algorithm you have to use? If there is a categorical data, that is called logistic regression. Okay.
Okay.
So today we'll study on logistic regression. So whatever we studied yesterday, linear regression, that apply on continuation output. You got it? So now see, logistic regression, it is also a supervised learning, but apply on classification problem. Either pass or fail, selected or rejected. Yes, right? Is got
Okay.
malaria or not? It's kind of problem it will predict, right? If see, if you go and if you are having fever something, and how the doctor predicts, it will check up some checkups, and they will have some report. In the report you have so many values. By analyzing so many values, they will say only two things: either you are having malaria or not. Yes or no?
Yes.
Yes, there is only two categorical data, right? Either yes or no. So there you have to use logistic regression. That is nothing but a classification. You are classifying either yes or no. Okay, that kind of data if you have, you will use logistic regression. If I take like example data, let's take same example, whatever yesterday I took. Let's take a study hour and pass. This is X and this is a Y. I'm taking only simple data. Let's take you are studying 1, 1, 2, 3, 5, 6. Okay. So see, if you see the output here, how many labels are there?
Values, only two values, 0 or 1.
2. Yes. Either it will be 0 or 1. So 0 means what? Fail. Passing status. Okay. So 0 means what? Fail. 1 means what? Pass. Okay. Which means what? In this data you have, in output you have only two levels of data, either 0 or 1. Is there any other 0 or 1? If you see the previous data, like whatever is that is there here? See, the same example, if you study 1 hour, like hours and marks. When you study 1 hour, you got 40. When you study 2 hour, you got 50. And you study 3 hour, you got 60. See, here the output is can be anything.
Yeah.
Which means what? Here the output is a continuation value. But when you see here, output is a, it's kind of a categorical data. That categorical data only you call it discrete value. Have you heard about what is discrete value? I mean, have you heard ever like in BTech or somewhere discrete
Yeah.
math?
Yes.
Yeah. Discrete means what? We will have only categorical data. Either see, discrete means this. This is 0. This is what? This is discrete. We don't have any value, either yes or no. This kind of value is discrete. And same discrete value you call it categorical data. Categorical data means you'll have only category, you don't have a continuation value. Okay, if there is this kind of data is there, if you wanted to suppose someone say like, if you study 4 hour, what is the prediction? You will be pass or fail. If someone asks you, right? So you need to predict. If you wanted to predict this kind of observation, then you have to use logistic regression. You got it?
Yes.
Yeah. Now we'll have basics like mathematics, how it works. Then we'll take scikit-learn algorithm code. Let's take in the previously what I have studied. Y is equal to what? What I told? Y equal to basic equation.
Y is equal to
X1 WX
plus
plus
B.
Yeah. Yeah. W1 x1, W2 x2.
plus
This also.
And
W1
plus
x10 plus
n
B.
x plus
Yeah.
B.
Yeah, this is a basic equation, right? For any, if there is a one features, you will have only W1 x1 plus B. If there is a two features, it will be W1 x2, W1 x1 plus W2 x2 plus B. Okay, this is a basic equation, right? Now, see this equation we have applied on linear regression, right? Now tell me what is mean squared error? Do you remember or forget?
No, it's a epsilon. Sorry, sum of
Sum of 1 by n.
1 by n W. No, it's a different
Yeah,
deviation.
difference. Deviation. So difference between y and y cap.
Y
Y
gap.
means what? Y means actual
Y is
value. Y cap
output
means predicted. Yeah.
value.
Y cap means predicted value. So what is gradient descent algorithm?
So this
The
is
formula for the W, find out for the W. W equal to W minus alpha dou
alpha d,
J
d
by
by
dou W.
d
Yeah.
dou W. Yeah.
J, this one only J.
Yeah, J is the mean square.
Yeah. Right. For the similarly for the B, B will be B minus alpha dou J by dou B. As you are finding for the B, it will be dou J by dou B. As you are finding for a W, it will be dou J by dou W. Right. These are the three things we have used, right, for the linear regression.
Yeah.
Yes. Similarly, we'll use for the for logistic regression also you'll use this kind of equation. Like let's go for the logistic regression. But logistic regression, but here the output, this is a predicted output, right? Y cap. This is the mathematical equation you need to find out. Am I right? In the linear regression.
Yes, y cap is the predicted value.
Yes. Now in the logistic regression also we'll use same equation, that is y cap. Instead of y cap, like if you find out the y cap here, let's take for the input, let's take w1 is a 2 and w2 is a 3, b is a you got 3. Okay, for this input let's take x and y.
Yeah.
1 2 3 5 6, this is 0 0 0 1 1. Okay, this is the actual value, right? Actual data set. From the actual data set you got this values, you assume, just assume this y cap will be, tell me what is the y cap will be. Sorry, here
Y
it will be only w1 because only you have only one feature.
yeah.
uh, so what will be the equation?
Y is
2
equal to
2x
2
plus b,
1 2x plus
2x plus 3. Am I right?
yes.
Hmm. So now if so now what is the actual value for actual value? Let's find out y. Y at x equal to 1. How much you are getting? Y at x equal to 1?
0.
0. So what is the y cap at x equal to 1?
Y minus
Y cap. Apply this 1 value here. How much you are getting?
5.
5. See here, but you have in output the categorical values either 0 or 1. But from the equation, what you are getting? Some continuation value. Don't confuse here. Here we will use one more separate equation to suppress this 5 value to 0 and 1. Okay. If I go directly, if I tell sigma, you have to use sigmoid function for the logistic regression. But why to use the sigmoid function? That's the reason behind I'm telling. Okay. So here, see, ultimately I need to find out the error, right? I need to find out the error. Y equal to y cap. So y equal to y is 0, but y cap you are getting 5. Is the 5 is a categorical data?
No.
5 is not a categorical data. 5 is some continuation data, which means I need to suppress this value in between 0 and 1. Whatever you have to get output, that should be in between 0 and 1. Am I correct? Because there is
Yeah.
no any other value other than 0 and 1. Right? So how to make this value into the 0 and 1? For that you have to use one function called sigmoid function. Okay, that function called sigmoid function equal to y cap equal to 1 by 1 plus e power of minus z. What is the function? Y cap equal to 1 by 1 plus e power of minus z. So here z is nothing but initial you assume that this is a y cap is a z, but here z will be 2x plus 3. Okay. So now this, instead of directly applying here, you need to apply on here. Are you guys confused?
A little bit, yes, sir.
Yeah, it's a little bit confusing. See, what I told, ultimately we need to find out the optimal value of W and B, right? To find the optimal value, you need to find out the error, right? So for to finding the error, you need two entity. What are the two entity? Actual value and predicted value. So actual value you will find out in the data set, but the predicted value you need to find out from the what are the assumption you made initially, W and B. From there you need to find out some value, right? But that value you are getting a continuation value, right? So that value, see, this is a continuation value, and you have a category value. Can you compare? Can you find out the error? It's a difficult. You cannot compare, right? Yes or
Yeah.
no? So for that, to make it this prediction value out from the continuation value to some the categorical value, you have to use sigmoid function. So how it convert in between 0 to 1, we'll see. So at x equal to 1, how much you got y previously? 5.
5.
So now you assume that y is a z. Now how much you will get z? 5. Now the apply at x equal to 1, what is the new y cap? 1 by 1 plus e power of minus 5. You got it?
Yes. But
Uh,
we have to find the E value, right?
e power of minus this value will be something 1 by 1 plus e power of 5 means 1 by e power of 5. Okay.
Mm.
So definitely this value less than 1. Can I say less than 1?
It's a, yeah, it's in a denominator, right? Yeah, it should be less than.
Yeah. Because in numerator you have only 1. But in denominator, definitely this value is more than 1, right?
Yes.
Yes. Let's take this value, you got 1.2. This value. Definitely this value will be more than 1. So 1 by 1 point, somewhat you will get 0.92 something, right? Now see, that continuation value you converted into a value which in between 0 and 1. Now can I compare at x equal to 1, you got 0.9213. Actual is 0. What is the error? Error is 0 minus 0.923. What is the error? 0.923. Right? So what is the ultimate goal here? To decrease the error.
Sir, this is called sigmoid function. What does it mean?
This is called sigmoid function. Listen, if you're not understanding mathematical clearly, see it is not required for the coding, okay? But you have to know, like, they will ask only in, like, in the interview only they will ask what is sigmoid function, how to implement like logistic regression, right? Anyhow you will get one linear. See, anyhow this up to here, this is a linear equation only. That linear equation you need to convert into logistic regression. Okay, how to convert a linear regression into logistic regression means you have to apply sigmoid function. By using the sigmoid function, you will suppress that linear value into a logistic value that is nothing but a in between 0 to 1. Okay, can I say
Sir, I have a
uh,
doubt here. Here, why
yeah,
we are taking Z as Y? I mean,
why you are taking
Z here, Z is represented as 2x plus 3, right? Which
uh,
is the Y value, right?
that's what I'm saying, right? If I take directly y, this is not a y, right? Now this is the 5 you got, right? You assume this is a y, 5 is a y cap, but this is not the final value, right?
Yeah.
This y final value is something after sigmoid function. You
Okay.
got it?
Yeah.
That's why here
I
uh,
one doubt, sir, here. Here in
yeah,
the
yeah.
top, you have written Y cap is equal to 2x plus 3, right? If you go up. But if you see the equations that we have written, it is W is equal to, sorry, Y is equal to W1 x1 plus W2 x2. That's how we have written, right? It's not Y
But
cap.
yeah, but here see how many features are there here.
Only one teacher. That's why it is 2x. I understood that.
uh,
But why this is Y cap? Why it should be Y, right? Y is equal to 2x plus 3, right? It's not Y cap.
yeah, I think you are thinking, okay, fine, good. So y means actual value, right?
Yeah.
So actual value there in data set only. You are not finding anything actual value.
Here we are only going for predicted value. Okay.
Yeah, we are prediction value. See,
So in that case, the
ultimately,
linear regression expression should be Y cap is equal to Wx plus B, right?
yes.
Okay. I mean, I'm
Yeah,
writing.
yeah, okay. Okay.
Yesterday it
I,
was
I,
we have
I, I I
written.
got it. I got it. Your confusion.
Yeah.
I written every time y equal to wx plus b. That's why you're confused.
Yes, sir.
Yeah, yeah. That is not, that is a y cap.
It's Y cap, right? So can I correct that in my book?
Yeah, 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 yeah. That is y cap. Okay.
Oh,
Y already there in the data set. We no need to find out that. Okay.
okay. Okay, sir. Okay. Now it's
Yeah.
clear.
Yeah. Now the ultimate is y cap is a prediction, final our model, right? Ultimately, you need to correct this mathematical equation by comparing actual value. Right? You are correcting this equation means what? You need to find out the optimal W and B value. Am
Yeah.
I
Yeah.
correct?
Correct. Correct. The weights and the constant. Yes.
Yeah,
Optimal one.
yeah, yeah. So you ask one more question like why
Z.
Z here? Z equal to
Yes.
WX plus 3.
Yeah.
Yeah. So what here I told directly if I take Y cap equal to 2x plus 3, but here you are getting how much value you are getting?
Higher.
5 value. So I need to suppress this equation.
Mm.
Output should you should get only in between 0 to 1.
Mm.
So that's why I applied instead of here I have applied sigmoid function.
Correct. Yeah.
Okay, so here this is a here I applied this equation. Okay, when I here applied this equation means you are converting 5 into here, which means what? I need to apply 1 plus e power minus 5. Then only
Correct.
this 5 will convert into one value that is in between 0 to 1. That's why I applied here. You got it now?
This one I understood, sir, because
Uh,
uh, here we are actually, if you see
hmm.
okay, the equation, it was like Y cap is equal to 1 by 1 plus e power minus z, right?
Yes,
Whereas
yes.
here, the 5 which you have just now written, it is the Y cap value only, right?
No,
At
no,
x
no.
equal to 1.
Yeah, don't confuse. Yeah,
You see here,
it's
at x is equal to 1, Y
no,
cap
no, no.
value is 5.
Yeah, yeah, I got it. Your confusion. So here, why you are going for this? For that, I have written here. This is not an actual y cap. Okay, if I directly take y cap like this, you are getting like this. That's why I need to convert this y cap into like this.
Okay. So here Z value is what? What is the Z value that we are
That
taking?
value is the linear value, that is w1x. Here z equal to, here actual z equal to w1 x1, w2 x2, wn xn plus b.
Okay.
You got it? I intentionally written here because if you do like this, you are getting like this. So the same thing I need to convert into, instead of y cap, this equation will be z.
So
Now
you
the final y cap will be 1 by 1 plus e power of z.
okay. So just sorry to mention. So here the Z is equal to W1 x1 plus W2 x2. This is the y cap for linear regression, right?
Yes,
Uh,
exactly.
but for
Because
logistical
there
regression,
in linear regression, we no need to care of output values.
because okay.
But here we need to take care of output values. The
But
output value should be in between 0 to 1 only. But in linear regression, the output can be anything. Doesn't care.
okay.
You got it?
Yeah.
Yeah. That's why I changed this equation into Z, and Z I applied here, and this is a final equation.
Okay.
Now here final y cap equation will be y cap equal to 1 by 1 plus e power of w1 x1, w2 x2, and so on b. You got it? Now,
Yes, sir. So okay.
yeah, ask.
No, sir. Okay. No. So this is the equation. Okay. Now it's clear. Previously, when I thought y cap is equal, because it should be minus 5, right? See, when we found, I
Yeah,
thought
yeah,
it is the error. Uh,
yeah. No,
then no, that is not the error. Okay.
not
It
the
is.
error. We are changing the equation because it is a logic. We need to take care of output also.
Sir, is there any what do we call this expression like W1 x1 W2 x2? It is y cap, right? Can we say it's like the predicted value of linear input?
See,
Can we say
see,
that?
predicted value of
Linear input. That's what I said. Can we say that? Whatever it is
predicted.
there, the e power something W1 x1 plus W2 x2
So
until
yeah, I got it. What to call here in
yeah.
both in linear regression logistic. This is, we call it linear relation between input and output.
Okay. Yeah.
You got it?
Yes.
This equation represent the relation between input and output, right?
Yeah. Correct.
Yeah. This is a linear equation, linear representation equation. That's why, see, if you see the both the like algorithm name is linear.
Yeah. Correct.
First one is linear regression, second one is linear logistic regression. But see, sorry, both are the regression, right? So linear regression, logistic regression. Linear means you directly take value from the linear equation, but here logistic means what? That linear equation value only you will suppress by using sigmoid function. Okay.
Yeah.
So both are the, in both you will use linear equation only. Only extra thing you will apply what? This sigmoid function you will apply.
So
Why
we
do
can
you apply the sigmoid function? To suppress the value in between 0 to 1. You got it now?
Yep.
Hello, Monica. You are not getting anything?
Yeah, I understood actually. So
Yeah,
I'm just
okay.
listening. Yeah.
Yeah, actually you joined only yesterday, right?
Yeah. Yes.
Yeah. Okay, fine. Actually, machine learning only these two algorithms is mathematical equation. Okay, because these two algorithms we apply on all the algorithms. Okay, so these two algorithms you should know the mathematical equations and how to evaluate, how to interpretation you have to know, right? Uh, in if you go any interview, definitely they will ask linear regression and logistic regression. I'm telling keep on. These are the ABCD for the machine learning. Okay, that's why I'm going in detail, but I can directly say that I can directly go to algorithm. First take a input and find out the error. Error is nothing but y minus y cap, and then apply on the like a gradient descent algorithm. It will keep update. You will find out the final w value, b value. That's it. But this is the funda behind it, how it works. You got it? So now this is the mathematical funda behind it. Now you find out the error, but in previously you use one function called j equal
Yeah,
to what?
mean square error 1 by
Mean
n.
square error. Can I use same thing here?
Uh, no, right? That is for linear
Yeah,
continuous.
yeah, yeah. So
Now,
here, oh, here j will be some more equation. Okay, the j is like their j is, see, if you see the j is a what? MSc, again this will give you some random value, right? It will not give you in between 0 and 1.
yeah, it can be a value. I mean, if it is less than 1,
Hmm. Less
if y
than
cap
1,
is less than 1,
hmm,
okay, yeah, got it.
till you will get, if there is a 100 point, for the 100.1 square plus 1 square plus 1 square, again you will get what? You will get somewhat value, right? Some numeric value.
Yeah, yeah,
You got it? But here only three inputs, but in practical you will have so many rows. In thousand, in 1 lakh rows. In 1 lakh rows, 0. Suppose this value you got 0.02. The same thing 1 lakh value of 0.02, if you add sum of, ultimately you will get some value. You got it?
but that value is between 0 to 1, sir.
Uh, that value in between.
Will be 0 to 1, right? The MSc for logistical regression, because our output is always categorical, that is 0 or 1,
Uh,
right?
uh.
So then the y cap will also be in between these values, right?
Yes, yes.
Or 1. That
Uh,
means the mean square value will
hmm,
also be in between that one, right? Like let's say if it is, let's say 1 minus y cap is 0.5, then
uh,
it's 0.5 square, which is 0.25,
uh.
right?
Yes, right.
And
There is a summation. Do you see summation?
yeah, that, yeah, correct.
Which means you are finding for only one row of input. So
Uh,
at one iteration, whole row should be calculated.
oh, yeah, yeah, yeah. Okay.
You got it?
So this is only for one row mean square. So
Yes. So every time you update now, every time you update W value, B value, you will not calculate only one row. You will every updation you will calculate whole row. I mean, so whole all the rows,
yeah, okay.
because you have to update by seeing all the data in dataset, not the particular one row of data. Did you got?
Yeah, got it. That's why it will be more than one.
Yes,
The
yes. It's a very good question. Even when I started like studying here, even I also used to thought that In every iteration, it will calculate only one row value. Again, in the second value, again it will calculate like that. You also think like that?
Yes, sir.
Yeah. So it's fine. It's this is a very good question. Like in every updation, you need to take care of whole data. Whole data means what? All the rows.
Okay.
Yes, you got it. Now here we'll use some J equation. You will not use mean square error. You will use something called cross entropy loss. Cross entropy loss. Okay. This loss equation is somewhat, it's not difficult. Y log y cap plus 1 minus y into log 1 minus y cap. This is the equation you have to remember. How you got this equation? This is a mathematical derivation. I will not go in detail. Again, you will feel like what the you will frustrate. Okay, I will not go in detail. If I get time in the future, I will explain. Okay. So tell me what is mean by y here?
Y is the actual output.
Yes, y is the actual. Log y cap means
Predicted value.
yes, predicted value.
N is the number of rows, iterations.
Yes, n is the number of rows. Right? So by using this j function, you will use this is the error. This is a what error? In linear regression, how you used to find out the error? Just y equal to y cap here.
Y cap.
But here you need to find out by using this. Why? See here, why we are using log y means, let me tell, so that you will it will feed into your brain this equation. Let's take, now you got output. Now this assumption all are for prediction of 1. Prediction of, there is how many classes are there in the data set? You have 1 and 0.
Okay.
Right? This is for prediction of 1 class. This is a prediction of 0 class.
So here class in the sense category, right?
Yes, class means category. Now see, y log y cap means this is for 1 class. 1 minus y log 1 minus y cap means this is a 0 class.
Okay.
Okay, remember this so that this equation will be fed into your brain. Okay, so why this is a 1 class, why this is a 0 class, right? Do you got any question like this?
Yes.
Yeah.
See, let's take, yeah, have you studied the probability?
Yes.
Yes.
If probability of S is P, probability of no is what?
1 minus.
Yes, 1 minus P, exactly. Here
Okay.
also, y cap is the probability of yes. What is the probability of no? Y minus y cap. You got it?
Okay.
You got the intuition behind this formula?
Got
And
it,
this
yes.
is the actual value. So by combining, you will say the final error, right? This is a way you need to remember. Now, can you able to remember? You should not by heart. You should remember.
Okay.
You should remember the logic. Now, one more trick I will tell. See, now this is for what? For the S,
One.
no, 1.
Yes.
Now let's take probability of y cap, you got 0.01. 9 for 1 only, for actual value of 1. Okay, for actual value of 1, the probability you got 0.9, one more 0.5, one more 0.1. So which one is the more error?
0.1.
Yes, 0.1 should be more error, right? If I apply, why you are applying log? That is a behind I'm telling. If I apply log 0.1, how much you will get?
So yeah.
You will get what? Log 1 by 10 means what? 10 power of minus 1. You will get 1. Yes, right? Suppose if I apply here log 0.9, how much you will get? Somewhere 0.0001 you will get. See the difference? Y cap, if you are getting 0.1 means what? The error is more. When y cap is 0.9 means what? Error is less. That's why you are using log. You got it?
Yeah.
I mean, this is not exactly. The exactly is that somewhat different. You will use Bernoulli equation. You need to find out the equation and all. But this is a intuition behind it. Why you are using log and why not directly y minus y cap whole square and all. You got it now, at least.
Yes.
You should remember. Ultimately, logistic regression, the same equation, logistic regression. So here also, what is our goal? Finding parameters only goal.
Parameters.
Yes. How will you find out the parameters? By using gradient descent algorithm. Okay. What is the gradient descent algorithm? Weight equal to weight minus alpha dj by dw. For the b, it will be b minus alpha dj by db. See, everything similar. Linear regression and logistic regression. What is the difference only? This is a j function. J function, and when you are finding y cap value, the y cap value, you have to apply extra sigmoid function. Am I correct?
Yes.
Yeah.
So normally, how do you find out the weight and b values? Initial, you need to take some values. Right? Initially, you need to assume some value. Let's take you assume the w value is 0.2 and b value is 0.5. Okay, this is iteration 1. You will run so many iteration, right? You run this is iteration 1. For the iteration 2, tell me what is the weight value, new update. How will you calculate the new update for the iteration 2? Already asked you.
Old one will become our values.
Yes, which means 0.2 minus alpha may be, I assume, 0.01. dj by dw, let's take you got 2.
Okay.
So how much you will get? Let's take 0.2 minus 0.02. How much you got? 0.98. 0.19198. Right? Is the w value changing?
Yeah.
Yes.
Similarly, how will you find out the b new value? B equal to
Is 0.5 minus
0.5 minus 0.01
0.01.
and dj by db, you will not get 2, you will get somewhat value. Let's say you got 3. So how much you will get? 0.5 minus 0.03. Right? You will get somewhere 0.473. 47. Okay. Likewise, you need to find out everything. In iteration 3 you may get a different value. In the iteration 4 you will may get a different value. But where I need to stop?
Until the error is minimum.
Yeah,
No, the weight
until error
value.
is minimum means what?
The weight values are the same, weight and constant value.
Yes. When will be error will be 0? Error ultimately will not be 0. Error should be minimum.
Minimum.
Okay, which means what? Error should be minimum means what? This values should not change. If this value will be 0. I told yesterday I have given a one curve. This is a minimum point. When you
Yeah.
come here to here, you will get here. Slope is 0. When here you are coming here means what? This value will further it will change.
No.
No, which means where I need to stop? If the consecutive iteration values are same for weights, you need to stop there. You got it?
Yes, sir.
Yeah. So this is the logistic regression algorithm mathematical intuition. Okay. Let's find out. Let's go to scikitlearn code. See, here machine coding is very simple, but mathematical behind to understand is difficult. Am I correct?
Yes.
But at least you guys are understanding or not?
Yes, sir.
Yes.
I have one.
Yeah.
Question.
Ask.
So, can you tell me the sequence of using these, MSc gray descent algorithm and then the linear equation?
Hmm.
So first we find out the predicted value, right? But even to predict the value, we need the weights, right? So
That's what I'm saying. You have to assume some weights initially.
yeah, correct. So first we will assume the weights, and then
Hmm.
by using gradient descent algorithm, we find out the weights,
Hmm.
right? And then
Uh,
we keep these. I mean, we place these weights in our predicted value equation, whatever that equation that
hmm.
we have,
Hmm.
and then we find out the predicted value. And by
Hmm.
using the predicted value, we get the mean square error, right?
Hmm. Hmm.
And once if it is, so this is for iteration 1. Then we
Yeah.
do it again. And then,
Again, same process should keep continue.
so I just wanted to know the sequence. The
Hmm.
first thing is like assume weights and constant. First
Yes.
step 1.
Yes.
Step
Yes.
2 will be using gradient descent algorithm to calculate the weights and the
Hmm.
constants, right?
Hmm. Hmm.
And step 3 will be finding out the predicted value.
No, you are going in the wrong sequence.
Sequence, yeah, that's what can you please show me the
Yeah.
sequence of these steps that we need to use?
Okay. Let me tell. So, give me one. Do you see my screen?
Yes, sir. Yes,
Okay.
now we can.
Yeah. So our ultimate goal is you need to update weighted bias by using W minus alpha dj by dw and B minus alpha dj by db. So ultimate goal is to update these values. To update these values, you need what value?
J value.
J value. You need J value. I'm telling for the linear regression. J value is what? 1 by n y
Sum of
minus y
y
cap
cap
whole square.
square.
Right? To update W value, you need J value.
Yes.
Right?
Yeah.
To find J value, you need
Y cap value.
Y cap value.
Okay.
Right?
Yeah.
To find out Y cap value,
we need that linear expression.
Wx plus b. Right?
Yeah.
To find out Y cap value, you need initial WB. Which means what will be the process? This will be the process.
Yeah. First we assume it.
Yes.
Values.
Let me write here xy. Let's take 1, 2, 3, 5, 10, 15. Okay, this is the initial input. Okay. So what is the step one? Step one is assume. Here, how many features are there? Only one features. That will be only one weight. Let's take w equal to 1. Only b one bias value 2.
Yeah.
Okay. Assume weight and bias, initial bias. Then if you assume initial weight and bias means what? Initial predicted value equation is what? Wx plus b means what? X plus 2.
Yeah.
Am I correct?
Correct.
This is a step 1. So what is the step 2? Step 2, find the error. Find the error for each row. Do you got? Each row you need to find out. Okay. In this process, what will you do? For x equal to 1, what is y predicted? 3. For x equal to 2, what is y predicted? 4. So what for x equal to 3, what is a y predicted?
5.
5. Now for this, for here, what is the error?
Oh, okay.
Y minus y cap is 5 minus 2. Here, what is the error? 10 minus 4, 6. What is the here error?
15 minus 5, 10.
15 minus 5, 10. Right? This is done. What is the step 3?
Step 3 is
find out MSC. MSC is nothing but J. Am I correct?
Yeah.
J equal to what? 1 by n sigma y minus y cap whole square. Am I correct?
Yeah.
What is the n value here?
A number of rows, which is 3.
3. So this one is a for every, right? Every point, how much you are getting error? The y minus y cap whole square. What is the first error you got?
2.
Which means 2 square. Second one, 6 square plus 10 square. How much you got? 4, 36, 100. How much you got? 140 by 3. Now you got the J value.
Yeah.
Right? This is the way of finding J value. What is the step 4 will be?
Now, once we know the J value, we need to get the W and B values.
Yes. That is the finding W and B values.
Like the minimum optimal value.
Yes. Yeah. In this step, you keep on update. You got it? So this whole process you keep on run. These 4 steps you run in iteration 1.
Okay. Got it. Okay.
Iteration 2 also keep on run. Again 4 steps you need to run. In iteration 3 again you keep on run 4 steps. When you have to stop all the iteration, let's take at iteration 99, you got weight value is something 4, bias value is 8. If iteration 100 also you got weight equal to 4, by is equal to 7.999, which means what? Is there any changes you are finding?
Yeah, the weight
Only
is,
small minor changes.
yeah,
So which means what? I need to stop here. There is no much changes in between iteration 99 and iteration 100. Let's take, if you run one more iteration 101, weight will be 4, bias will be 8. Are you finding any changes in all the iteration?
no,
See, this value to this value not changing means what?
so it
W
doesn't
equal
matter.
to W minus alpha. This J value becomes 0.
0.
If this value is 0, then only this value equal, right? Previous value will be equal to new value. When this is becoming 0 means what? J becomes 0. If J becomes 0 means what? Loss is 0. You got the
Yeah,
logic?
yeah,
J means what? This is a collective loss. When the collective loss is 0 means what? You find out the optimal value. You got now?
correct, sir. Yeah,
What are the steps you need to follow?
yes, sir. Now it is clear.
Okay. So now you cleared it. Linear regression, logistic regression.
Yes, sir. Sir, one doubt here.
Hmm.
So we need to stop until we get same consecutive both weight and constant, or any one is fine.
No, both.
Both, right? Okay.
Yes. But in practically, the both will not be exactly same. Okay. In practically, we need to give some condition, approximation condition. You got it? Which
Yeah,
means, suppose in practically, you will not get approximately same both consecutive iteration. So there we will set something W100 minus W99. If something in the difference will be 0.1, then stop here. You got it? Which means what? 1.1. W equal to 1.4.1 minus 4. How much you
point
got?
one,
0.1. Now see, this weight of 100 is 4. 4.1. This is 4. How much you got?
point one.
0.1. Which means what? I can stop here.
So is it
Practically, we write the code like this.
okay?
Which means there is no some much difference.
So this difference is acceptable until point
Yes,
one.
yes.
Got to know.
Minor difference is acceptable. That's why I told her no model is a perfect.
Yeah, correct. Yeah.
Which means there should be no model is a perfect. It should be 98 to 100 in between the accuracy. Okay. In ChatGPT also not accurately perfect. ChatGPT is not giving a wrong answer sometimes.
Yeah, correct.
Yeah, which means that model also not a 100% accurate. That's what I'm saying. Every model is a not a 100% accuracy. There will be some minor error. So that minor error is acceptable.
Okay.
You got it?
Yes, sir.
Do you have any doubt?
No, sir. Now it is clear.
And now, if I ask any question in between linear regression, logistic regression, can you able to answer?
I think yes.
Yes. I mean, yes. Only you have listened the what I taught, but if you study again, you will
Yeah,
understand better.
yeah, that's okay.
If I give a like notes, and if you'll
Need to do
understand
the
better.
revision. Yeah, once I do the
Yes.
revision.
Yes. Yeah. And now you feel you understand everything. If I go further, three more algorithm, you will forget. So anyhow,
Wait.
I have written the notes. I will send this to
Oh,
algorithm.
Okay.
Yeah. What about Monica?
Yeah,
Yours?
I need to once cross check again. Like,
Mm.
yeah, understood, but again I need to verify once more.
Yeah. Actually, yeah, you joined little
Wait.
yesterday only,
Ah,
right? So,
yes.
mhm.
Mm.
So once you go into like notes,
Ah,
you might
yeah,
understand.
I will get understand.
Yeah,
Yeah,
if you're not understanding, you can ask. I will.
yeah, I'll come back. I'll get back to you.
Yeah.
Mm.
So this is a theory is done. Now let's go to code. Code is very easy. Just import the class and just apply. Let me go. Let me go to coding. Sorry. Sit. Okay. Let's go to. Do you see my screen
Sir,
now?
now it is. Yeah, now we can.
Yes.
Yeah. Give me a minute. It will take only 10 minutes. And these all things linear regression I started to explain. This is a logistic regression. So this is a logistic regression for the simple data set already I have explained. If there is a two features, let's see if you see this one also will have only
Zero.
categorical data. This is the
Mm.
exam score, interview score, depends on the this score. You are seeing either selected or no. So similarly, I have taken some. This is some assumption I took. To know already have explained. This is also some kind of data. Here, how many features are there? There are the three features are there. Depends on the glucose level and BMI level. Is you are saying that person is having the diabetes? Yes or no? Right? Yes means what? One. No means zero. Okay? So this kind of data you need to. If there is a this is the output, right? If there is a output is categorical data, then you have to use logistic regression. Okay. Uh, Already I told right to how to use logistic regression. Just we need to know need of this. So yesterday I told it what is NumPy, what is the
Mm.
scikit-learn. So
Yes.
just we need to import the NumPy. Why do you need NumPy here?
For
The library.
number.
Yeah, to represent the input and output in the array, right? So you need NumPy array. By using NumPy array, input these are the two features. Input you segregated, the output you segregated. Now you need to call the logistic regression. See, you imported, and previously you imported only
Linear.
linear regression, but here you just import logistic regression.
Logistic regression.
Yeah. Now you imported this. Now model dot fit xy. If you given xy means what? This whole all whatever I explain all the algorithm, it will process everything internally.
Okay.
Okay. So, I told you that coding is very easy. Like in machine learning, coding
Ah,
is just you just import the class and models. You just do it. But only understanding is tough. Okay. Now, if I run it, I need to run this one first. right? Now see. So what you got in output? Model dot fit means what? Logistic regression. You got the logistic regression in the output, which means what? Now your logistic regression model is implemented. Which means implemented means what? Weight and bias value, optimal value find out. Okay. Now suppose now the model is implemented. Suppose I wanted to predict if there is a x value is a 6, x1 value is a 6, and x2 value is a 36, how much value you will get? Either you will get 0 or 1. We'll see. How much you are getting?
1.
1. Which means if there is a 6 and 35, then you are getting class 1. Let's take, let's change here. Let's take 0. How much you are getting? You are getting 0 class. Okay. This is only logistic regression.
Okay.
It feel like very simple, right? But what is the logic
Program is
behind
simple.
all? This is the logic behind all. See, scikitlearn made our life is very easy to just to important. You just call the fit method. But in the logic, if you write the scratch, it will take so much time, right? You will implement the J function. You need to implement the W function, P function, and all. And one more thing, see here only I am taking only very simple data, but in further you not work on the simple data. I will give a big data some Excel file. I will download Excel file in 3 GB, 4 GB data. Okay, that data you need to import. That data you need to import and you need to analyze. Here only numerical value only there, but in actually you will have numerical and text values also. You got it? That numeric text value, yes, no, the city name, all those things you need to process. You need to process means what? All the text data, all the things you need to convert into numerical data. Then only, then only this model you will accept x and y. This x and y value accept. This x should be always a numeric value. Y also should be always a numeric value. Okay. So in the further we'll discuss like that is called data analysis, EDA. We call it EDA, exploratory data analysis. When there is a big data is given, you need to analyze the data, you need to pre-process, then you have to make it available for the model. That whole pipeline you call it EDA, exploratory data analysis. You got it? Is there any doubt here in code? In code you will not get any doubt. Anyhow, I will save this code to this. This is only simple code. In the actual code, it will not be like this. It will be very lengthy, right? Not lengthy, like we'll
Our
have to.
parameters are more, right? Like,
Here are only 3 parameters. So, in the further we'll discuss we'll track on while your data analysis will see. First, we'll finish the machine learning so that we'll apply some while doing the project. We'll take some real time project
Okay.
like segmenting, classifying, and all those we'll see. Do you have any doubt?
no, sir.
No.
Right. Okay. So then I will send the notes and this file. Have a look. Then can you wrap up? I have to go to office.
Yes, sir, sure.
Sure.
Yeah.
Thank you so much.
Yeah. Thank you.
Thank you, sir.
Thank you.